Problem 43 in section 6.1. The following table presents the probability distribution of the number of defects X in a randomly chosen printed circuit board. A. Find the probability of getting 2. So in this problem, we can see that to get 2, the probability is 0.1. B. Find the probability of 1 or more. 1 or more, that means 1 or 2 or 3, because 2 and 3 are more than 1. So 1 or more, that means there are 1, 2, 3 for the X. By the addition rule, we have the word or. You will add the probability of 1 and the probability of more. The probability of 1 is 0.3. The probability of more is, that means 2, is 0.1 and 0.1. So we got the answer is 0.5. For part C, find the probability that at least 2 circuits are defective. So you have the word at least 2. At least 2 means more than 2 or equal to 2. At least 2 means 2 or more. It means 2, 3, 4, 5, and so on. So we have at least 2. In this case, this is probability. At least 2 is mean probability of 2 or 3 in this case, because we only have up to 3. So we will find the probability of 2 and probability of 3, then we add them up. We look at the table. So we have these two numbers, and that is 0.2 when you add them up. Problem D, find the probability that no more than 2. So no more than 2 is probability of 0 or 1, because not more than 2. So probability of 0 plus probability of 1. So 0.5 plus 0.3 is 0.8. In part E, we want to compute the mean, and in part F, we want to compute the standard deviation. Okay, so I will do the table again in the different directions. So we have X and we have P of X. We have 0, 1, 2, and 3. And we have the probability of 0 is 0.5. Of getting 1 is 0.3, 0.1, and 0.1. So we recall the formula to find the mean is the sum of X multiplied P of X. So let's make one more column, and we do X times P of X. So 0 times 0.5, 1 times 0.3, 2 times 0.1, and 3 times 0.1. Now let's just go ahead and multiply the number. And after we do the multiplication, we will add, because we have a multiply here and we have the addition here. So we do the multiply already. So we add them up, and it's equal 0.8. In part F, we want to find the standard deviation. The formula to find the standard deviation is sigma of X is equal to the sum of X squared times P of X minus mu square. We need to have one more column, and we need to calculate the X squared times P of X. The X squared is 0, which is right here, times we need to square it and then times 0.5. 1 square times 0.3. 2 square times 0.1. And 3 square times 0.1. So basically we just plug in the number. We use calculator to calculate this, and we got 0, 0.3, 0.4, and 0.9. Then after we do the multiplication, we need to add them up because in the formula is the sum, right? It say the sum. So we add these up and is equal to 1.6. So let's plug into here is 1.6 minus sigma, minus mu, we already calculate in part E is 0.8. So we need to square that number. So 1.6 minus 0.64. And we use the calculator. 1.6 minus 0.64 is 0.96. This is the formula for variance, and the variance is sigma square. The sigma square is 0.96. To find the standard deviation, which is sigma, we just need to take the square root of 0.96 and we just go ahead and take the square root of that number. So we get 0.979795 and so on. And if we take 2 decimal places, so we get 0.98. For problem G, the circuit will function if has no defects or only one defect. Okay, so we want to find the probability for it works, right? So that means we want to find the probability of no defects or one defect. So no defect or one defect. So we have the word or is a keyword, so we use addition rule. So it's one defect. And you know that there's no common between them, so we don't have to do the subtraction. So you recall the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we do not have this part is because they are independent. Okay, so no defect, that means 0 defect, that means 0.5 right here, and 1, so 0.3, and is equal to 0.8.